So welcome back guys. Now we will going to study the functioning of a layer 2 device called L2 switch. So remember the problem of thrashing of rest of the machines which is present in the subnet when two machines communicate with each other. Let us deploy L2 switch in the network and understand how it solves the problem of thrashing. L2 switch is also called a bridge and it is a layer 2 device. So remember, any device is said to be layer 2 device if the primary functioning of that device is dependent on only MAC addresses. The L2 switch works only with MAC addresses specified in the Ethernet header of a frame, and therefore L2 switch is classified as layer 2 device. Similarly, if you come across any other layer 2 device and if that layer 2 device works with only MAC addresses, then it is obvious that that particular device will be classified as layer 2 device. L2 switch interface do not have any MAC address or IP address configuration. It has just port number which are just numerical values. So in this topology you can see that we have an L2 switch in the diagram, and this L2 switch has 4 ports, that is port P1, port P2, port P3 and port P4. L2 switch interfaces do not have any IP addresses or MAC addresses. L2 switch only have port numbers, that is numerical values of ports. You can see that the host machines E, D and F are present in the same subnet as before. So you can see that the host machine E, D and F are present in the same subnet with network ID 12.1.1.0/24, right? Layer 2 switch, which is also called a bridge, maintains a table called MAC table, and this table is populated using a procedure called MAC learning. So shortly we will going to discuss the concept of MAC learning. MAC table contains the mapping between the MAC address and port number. So we will going to discuss that what is MAC learning, how it is done and how it is used to populate the MAC table of L2 switch. Now going forward, you can see that here we have shown a fully populated MAC address table for this L2 switch. That is, MAC learning has already been done by this L2 switch, and using MAC learning, this L2 switch has populated its MAC address table. Now from the table, if L2 switch receives a packet with destination MAC address is equal to ME from any interface other than P4, that is, this L2 switch suppose receives a frame and the destination MAC address in that frame is specified as ME, right? So what will this L2 switch do? This L2 switch will look up in its MAC table with ME as a key. So with ME as a key, this is the matching entry in the MAC address table of this L2 switch. And therefore from this entry the L2 switch would know that it has to forward the frame out of port number P4. Right? So the packet or the frame will go out of the port number P4 because of this matching entry. So thus only E would receive the packet and no other machine in the subnet will unnecessarily thrashed with packet which is not destined to it. So here I apologize that when we talk about routing in data link layer, we should call packet a frame. So remember, a data unit which is being transmitted over a wire using L2 routing is referred to as frame. So you can see that in this topology, the L2 switch make use of its MAC address table in order to know that on which outgoing port number it should forward the frame. So if you do a little recap, if there was no L2 switch, then the frame still would have been delivered to a destination host machine E, but the host machine D and F would have also unnecessarily received the frame and therefore unnecessarily were being thrashed. But now L2 switch using its MAC address table completely avoids this situation. So going forward, now let us see how L2 switch populate its MAC address table. So you have given a following topology where you have L2 switch connected to 3 host machines E, D and F. So L2 switch or bridge makes an entry in the MAC table by inspecting the contents of Ethernet header of a frame. So remember the point that L2 switch inspects only the Ethernet header of a frame. So any kind of frame which has Ethernet header, when received by L2 switch from any port, the L2 switch inspects the Ethernet header of the frame, and based on the information in Ethernet header, the L2 switch takes an action. That is, it either populates an entry in its MAC address table or it decides to forward the frame on outgoing port number. Whenever L2 switch do not have an entry and do not know which port to forward the packet to, it floods the packet out of all the ports. So suppose this L2 switch receives a packet with the destination MAC address say M. And now suppose that L2 switch do not have any matching entry in its MAC address table which matches to the MAC address M. So in this case, this L2 switch will forwards the frame out of all the outgoing ports. So this is called flooding of frames with unknown MAC addresses. Now, L2 switch populates the MAC table by actually inspecting the source MAC address specified in the Ethernet header of the frame it receives. And L2 switch forwards the frame to correct port number by inspecting the destination MAC address specified in the Ethernet header of the frame it receives. The L2 switch populates its MAC address table by inspecting the MAC address specified in the Ethernet header of the frame, whereas L2 switch forwards the frame on the correct outgoing port number by inspecting the destination MAC address specified in the Ethernet header of the frame. So the L2 switch takes two actions. It populates the MAC address table and it forwards the frame using its MAC address table. Now let us discuss step by step that how L2 switch populates its MAC address table and how L2 switch forwards the frame using its MAC address table.